flood is an overflow of water on normally dry ground dew. Triggered by heavy precipitation, it is closely connected to the water cycle.
However, a natural disaster like flood is capable of causing severe damages to the biological systems, including the migration of domestic and wild animals and the water pollution caused by microorganisms.
In our Rube Goldberg machine, we model how flooding takes place, how it impacts the biosphere, and how it completes a full water cycle.
We use our knowledge in physics, biology, chemistry, design tech, and computer science to model the process of condensation, precipitation, migration, pollution, and evaporation.
First, condensation is simulated by the implementation of physics. The blue marbles on the track represent water. After the metal insert is removed, marbles start to accelerate down the slope due to gravity. Marbles' velocities increase as they arrive to the cardboard bucket, which represents a cloud. Cumulonimbus cloud is formed when warm, moist air rises. Since temperature decreases as altitude increases, the moist air cools down. When the water molecules in the air transfer their energy to something cooler, they slow down and their attractions cause them to bond to become a liquid. The rate of condensation is inversely proportional to temperature. Marbles' increasing velocity with respect to time represent the rate of condensation of water vapor, which also increases as time passes. The accelerating marbles can be explained using the work-connected energy theorem. Work equals the change in kinetic energy equals the final kinetic energy minus the initial kinetic energy. Since gravity acts downward to the center of the Earth as a component parallel to the slope, neglecting the kinetic friction between the track and the ball, the net force does the positive work to the marbles. Hence, the final KE is greater than the initial KE, showing an increase in velocity with the mass being constant. Then the water holding capacities of cloud and mountain are invented using rotatable buckets. As water continues to condensate, the gravity force of the droplet slowly increases. When the gravity force acting downward overcomes the air force acting upward, the water holding capacities of cloud is maximized and the precipitation takes place. Differently, the water capacity of the mountains is determined by various factors, including soil storage, soil infiltration rate, and water bodies. When the amount of water exceeds this land threshold, flood occurs. The process of gradually overcome the water holding capacities are demonstrated using buckets with rotation axis and center of mass axis misaligned. In this way, the rotational moment of inertia can be calculated using the parallel axis theorem. A increases as the total mass of the bucket increases. According to torque equals I times A, torque increases. Several large marbles act as bait at the other end of the bucket, providing negative torque, considering the clockwise direction as positive. Hence, the buckets gradually tip as more marbles fall into the bucket, which adds the positive torque. The buckets realistically imitate the time to overcome the water holding capacities of cloud and mountain, causing precipitation and flood. Precipitation is shown by a ramp, allowing the marbles to flow from the cloud piece to the mountain piece.
To represent the negative biological impacts the water cycle can have on the environment, we simulated flooding. When the water capacity in the mountain is exceeded, it can potentially cause flooding in the surrounding ecosystem. We set up a line of dominoes to demonstrate the direct effects flooding can have on ecosystems. 3 lines of dominoes led to animals, pushing them further away, and 1 led to the initiation of a chemical reaction. In pushing the animals away, we have represented changes in animal migratory patterns as a result of floods. For example, animals living near a river during a flood will be forced to be pushed away, creating some overcrowded areas and competitions in food webs between some species. Therefore, this can be seen as a domino effect as represented in our machine. If some animals' habitats are destroyed, they will be forced to leave this area. In terms of displacement, this can be true to humans too. After demonstrating the ecological effects, we had a chemical reaction take place to highlight the possible release of chemicals and bacterial pollution into ecosystems as a result of flooding. This is caused by bacterial buildup in the water supply as a result of flooding. Under the circumstances of a flood, bacteria enters the water supply or source very quickly and makes the water non-potable, affecting the lives of living organisms as there is a higher exposure to pollutants and a higher risk of ingestion when it is used in water crops in which we use as food. This leads to the contraction of sicknesses and diseases in both animals and humans. For example, E. coli, hepatitis A, and salmonella. These are all bacteria that can cause serious infections.
The use of silver nitrate and potassium iodide was used to represent the bacterial pollution caused by the after effects of flood. This double displacement reaction showed its reactivity through its prominent change of color and made the visualization of dirty sediment possible, resulting in the solution being cloudy. Evaporation is the process in which a liquid turns into a gas and is one of the processes of the water cycle. Evaporation occurs when sunlight warms the surface of water. The heat of the sun makes the water molecules move rapidly so they escape as a gas. The process of evaporation was exhibited through the boiling of water in a beaker. The boiling point for water is at 100 degrees Celsius and at a pressure of 1 atm. The boiling of a liquid in general depends on temperature, atmospheric pressure, and vapor pressure. When vapor pressure of a liquid is equal to atmospheric pressure, boiling will begin. When boiling occurs, the more energetic molecules change to gas, disperse, and form bubbles. These bubbles rise to the surface because there is less pressure acting upon them, and they then enter the atmosphere.
First of all, we use the edge of the cardboard so the leftover can be recycled in the other class. Also, all the materials we used are from maintenance shop that should be thrown away, such as wood, cardboard box, and plastic rail. For the convenient and eco-friendly construction, we chose to use materials from robotics lab, which are screws and nuts and metal rail, so we can make without glue. We use strategies from tech design to measure accurate angle and height for the railway.